right, folks, today we're going to talk about forces and we're going to talk about the motion that those forces can cause. So we'll start with a couple of concepts. First, obviously, a force, right? A force is a push or a pull, okay? And when you're pushing or pulling, or when anything is pushing or pulling on an object, all of the different forces that are acting on that object at the same time, when you add those or subtract or put them all together, that combination, we call that the net force. So that's basically the total amounts of forces. And of course, forces can cancel each other out, and we will talk about that. So we have a balanced force. A balanced force is a concept when you have multiple forces acting on an object, and like I just stated, they cancel each other out. So as you can see in the picture, you got two hands pushing on a box. They're pushing in opposite directions. If they cancel each other out, then you have a net force of 0. So a balanced force has a net force of 0, and balanced forces equal no change in motion. So if something's moving and you have a balanced force acting on it, then it's going to continue moving at the same speed. If something's not moving and you have balanced forces acting on it, then it's going to not move. There will be no acceleration. So balanced forces mean there's a net force of 0, which means there's not a change in motion. And the opposite of that would be an unbalanced force. Okay, when you have two things working on an object and they're not balancing each other out, then the net force is not going to be 0, and you're going to have a change in motion. Change in motion is what you get with an unbalanced force. So if something's moving, you can change its speed, maybe its direction, or if something's not moving, then of course you will accelerate that object and change it from not moving to moving with an unbalanced force. Here's another illustration of a balanced force. You have a 100 Newton force acting, pushing the truck forward. You have a 100 Newton force slowing the truck down. 100 newtons and 100 newtons. Those two cancel each other out, and you get a balanced force. So the truck does not move. It does not change its speed or motion. And an unbalanced force, when you have the 100 newtons pushing it forward and only a smaller force of 60 newtons trying to hold it back, then the truck is obviously going to move in the direction of the bigger force, which is pushing it forward. So the truck moves forward. Very simple. Balanced and unbalanced forces. And let's talk about that wonderful thing that we have spoken about before, friction. Friction is a force. Friction is an important force, right? Because it is the force that opposes other forces. It's an oppositional force. It opposes motion, right? So friction will always slow down something that is moving. And friction also helps to keep things from beginning to move. There are multiple kinds of friction, but friction, remember, it's an opposing force. It is the enemy of motion. It is always slowing something down. So let's talk about those types of friction, right? We have static friction. Static is a term we use in science to talk about things that are still. So static friction, something that is still, it keeps an object still. So if it's still there, then the static friction keeps it from beginning to move. Sliding friction, we've all experienced sliding friction. When you try to push something across a rough surface, it slows it down as that object is sliding. Rolling friction is a concept that we use with wheels that helps them to actually turn. Without that rolling friction, the wheel would not actually turn because you need an oppositional force for it to turn. And fluid friction. Fluid friction happens with, that's right, fluids. And remember, water, liquids are fluids, but also air is a fluid. So the friction that you encounter when you go through the air, that's also fluid friction. So we have 4 major types of friction. Static keeps things still. Sliding slows them down as they're moving or sliding. Rolling friction helps to make wheels move. And fluid friction is that resistance you encounter in water or in the air. So let's talk about another force, gravity. Okay, we all know about gravity. We all know it's a major force in our lives, and gravity is a force that it's an attractive force. It's a pull. Gravity is a force that pulls objects together because of their mass. Any object with mass has gravity. Here, this gentleman is fighting gravity to lift these very massive weight plates. So, since all matters have mass, right? All matter has mass, then all matter must experience gravity from the smallest thing, like a feather, or even a proton, neutron, or electron, very, very small, but they still have a small amount of gravity. And up to very large items, this obviously being the largest truck with the largest tire in the world, very big, moves a lot of stuff. Dude is very small, has to take stairs to get in there and drive it. Pretty big, very massive, lots of gravity. The Earth, extremely massive, therefore it has a large gravitational pull. Fortunately for us, it holds us on the planet, along with the atmosphere and all the air we breathe. So Earth, very, very massive, lots of gravity. Everything that has mass has gravity. The more mass, the more gravity. Very simple. Good old Sir Isaac Newton, he helped us to develop the theory, the law of gravity. Remember, in science we talk about laws. These are theories that have pretty much always been the same, always been able to be proven. Not much evidence against them, so we call them laws because we see them all the time, and it happens always. Law of universal gravitation, invented or laid down or written down by Sir Isaac Newton. And the law of universal gravitation is simple. What is gravity? Once again, it's a force, right? Gravity is a force. We're talking about forces. Gravity is a force, right? It's a force of attraction between two objects because of their mass. And gravity is a pulling force. It pulls. All matter has mass. All matter has gravity. All objects pull towards each other because of their gravity. So let's talk again about the universal gravitation law. Once again, all objects in the universe, that's anywhere, that's on Earth, we're in the universe, or anywhere out in space in the rest of the universe, right? They all attract each other. And the size of that force depends on two things. It depends on the mass of the objects that are in attraction, and it depends on the distance away from each other. So the law of universal gravitation, part 1. Gravitational forces increase as mass increases. Here we have our little chihuahua. Small mass, small gravitational force. Much larger dog here. Much larger mass, much larger gravitational force. So, gravity depends on the mass of the objects. Greater mass, greater gravity. So here we have the Earth and the Sun. Earth has a great gravitational force because Earth is enormous, right? It has a very large size. However, the Sun, of course, much, much, much more massive than the Earth. So two massive objects have a great amount of gravity. The Earth obviously more attracted to the Sun than the Sun is attracted to the Earth, but they are attracted to each other with a large force of gravity, which is why the Earth being so far away from the Sun, it still stays in orbit because of that great gravitational pull coming from that great mass. Law of universal gravitation, part 2. Gravitational force decreases as the distance gets larger, right? The farther away they are, the smaller that gravitational pull or attraction is. So these two things right here, they're closer. They have a pretty strong gravitational pull. These objects are just as close, but they are clearly more massive, so they have a stronger gravitational pull. But these two objects very far away have a much smaller gravitational force. Okay, so as you get farther away, gravitational force decreases. Once again, objects close together, gravity is greater. Let's look at here. Which one has a greater gravitational pull? Obviously, it's going to be these two objects because they are both more massive. This one is less massive, so it's going to have less gravitational pull. Same thing, right? It's these again because they're closer. If they have the same mass, then the ones that are closer are going to have greater gravity. Ooh, it's a little more confusing here. Greater gravitational pull. It's obviously going to be these two. They are more massive than these, and they're closer together than these. So close together with a great mass equals great gravity. We've talked about these concepts before, the difference between weight and mass. Once again, mass, folks, is the amount of stuff that is there. Okay, no matter where you are in the universe, your mass is the same. We measure mass in grams and sometimes kilograms. Your weight, however, that's that gravitational force that is exerted on an object. Weight is a force, so we measure it in newtons. And very important, the concept of the newton is the amount of force that it takes to accelerate 1 kilometer of mass by 1 meter per second. So how much force it takes to make that kilometer increase its speed by 1 meter per second, that is what the force of a newton is. So let's talk about the acceleration due to gravity. How does gravity affect us on the Earth? It pulls us down if there's no Earth in the way. So suppose homegirl jumps off the cliff here, then that acceleration due to gravity is 9.8 meters per second squared. So every second that gravity is affecting you as you fall, you accelerate by 9.8 meters per second. So every second you accelerate by 9.8 meters per second. That is a number you need to remember, 9.8 meters per second squared. That's gravity. We've already talked about the force due to gravity. Well, that's the acceleration due to gravity. So here we go. That elephant, and you got a very small feather. As you can see, acceleration due to gravity. You're accelerating. Now on the Earth, all objects fall at the same rate because the acceleration due to gravity is the same for all objects. All objects accelerate towards the Earth at 9.8 meters per second, whether it be that elephant or a feather. Gravity affects them the same. They accelerate at 9.8 meters per second. Some things fall more slowly because of air resistance. That's a form of fluid friction, right? That feather is obviously going to be affected by the fluid friction more than an elephant. That is why that elephant falls faster. We use air resistance to help us when we fall sometimes, right? That's what parachutes do. They increase that air resistance because you are being affected by a greater amount of fluid friction because the parachute has a much larger surface area, right? So air resistance it's that fluid friction we talked about. It's an opposing force, so it keeps you from falling faster. Okay, your body itself has a certain amount of air resistance, but that parachute is going to help you greatly. And because we talked about balanced and unbalanced forces, we can also talk about something that's called terminal velocity. When you're falling, or when anything's falling, gravity is accelerating you at 9.8 meters per second squared. However, as you fall, the air resistance, that fluid friction of the air, is resisting. It's pushing you back up. It's trying to slow you down because it's friction, right? It's an oppositional force. So if gravity's pulling you this way, that air friction, that air resistance, that fluid friction is pushing you in the other direction. So when those two forces balance, when you get that balanced force there, you get no increase in speed, no acceleration, no change in motion. So you continue to fall at the same speed. That speed is called your terminal velocity. There is a time when you're falling that you will stop accelerating. That is terminal velocity, caused by the force of gravity pulling you down and the oppositional force of fluid friction. Once again, we call it air resistance, pushing you in the opposing direction. So as you fall initially, you have an unbalanced force because gravity is greater than the air resistance. But then when you reach terminal velocity, it is then a balanced force. You are being pushed back by the air resistance at the same rate that you are being pulled down by gravity. They cancel each other out, so there's no change in motion, which means you're falling, so you continue to fall at the same speed. No change in that motion. Awesome, and we'll talk more about this in class.